Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wondered why some teachers seem to connect with students better than others, or how a presenter style can actually make you learn more? Well, new research dives into how the way a teacher delivers information affects how much students remember and feel like they've learned. You know how some people can just naturally capture your attention when they talk? They're smooth, engaging, and you feel like you are really getting something from what they're saying. This study looks at something called Instructor Fluency. It is not just about being good at your subject, but how you deliver it. Think about a lecturer who speaks with a dynamic voice, uses gestures, and has a confident pace. This is Instructor Fluency. The researchers were interested if this fluency actually helps students learn better or if it is just a matter of perception. Tested this by having participants watch instructional videos. Some videos featured instructors who delivered the material fluently, and others had instructors who were disfluent, meaning they hesitated, spoke in a monotone, or had awkward pauses. After watching, participants were tested on how much they remembered. The key question was, does a fluent delivery lead to more actual learning? So they measured how many key points or idea units students remembered out of a possible 10. Now, typically when analyzing data like this, especially proportions that are between 0 and 1, researchers might use standard methods like t-tests or linear regression. But as the paper explains, these methods have some big assumptions. They assume the data is normally distributed and can go on forever, basically. But proportions can be less than 0 or more than 1. This means these standard methods can sometimes give you wonky results, especially if a lot of people scored exactly 0 or exactly 1. So, the researchers in this paper decided to reanalyze this data, first using a standard Gaussian model similar to what might have been used before, and then using a more advanced method called beta regression. When they first ran a standard linear model, similar to a t-test, they found a significant difference. Students who watched the fluent instructor recalled, on average, about 8% more than those who watched the disfluent instructor. So, it looked like fluency did help. This plot shows the spread of scores for each condition. You can see there is some overlap, but also a difference in the average score. However, when they checked the assumptions of this simple model, they found some problems. Specifically, the variance wasn't constant, which is a big no-no for these standard models. They say it means the model could predict unrealistic scores outside the 0 to 1 range. This is where beta regression comes in handy. Beta regression is designed specifically for these kinds of proportion or percentage data. It's more flexible because it can handle the fact that the data is bounded between 0 and 1, and it can also model how the variability or spread of the data changes. To fit this beta model, they used a Bayesian approach with a package called BRMs. Now, a key point with beta regression is that the basic beta distribution doesn't like exact zeros or ones. So, for this initial model, they had to remove those cases from the data. This is a limitation, and they acknowledge that they strongly advise against nudging the data, which means slightly changing zeros to very small numbers and ones to very large numbers, because it can distort results, especially with lots of data. When they ran the beta regression, they found that the direct effect of fluency on the mean recall was less clear than in the simple linear model. The probability of direction, or PD, was 0.87, meaning most of the evidence suggested a positive effect, but it wasn't super strong, and the credible interval included 0, meaning we couldn't rule out no effect. It wasn't as clear. Cut as the first analysis. But here is where it gets interesting. By modeling the dispersionta variability, they found that fluency did have an effect. The variability in recall was different between the fluent and disfluent groups. Because their data had actual zeros, they then moved on to a zero-inflated beta model, or ZIB. This model can handle those exact zeros, and this is where the story really changes. The ZIB model fits the data much better than the standard beta regression, especially around the 0 point. It shows that the simpler model was missing something important. When looking at the mean recall in the ZIB model, the effect of fluency was still a bit inconclusive, similar to the beta regression. But the study really shines when looking at the zero inflation component. This figure and the analysis for the zero inflation part show something significant. A disfluent instructor was associated with a higher probability of students recalling absolutely nothing, that is a reduction of approximately 13%. The probability of this effect being positive was very high, with strong evidence that the disfluent instruction increases the chances of zero responses. They also explored a 0-1 inflated beta model, or ZOIB, which can handle both exact zeros and exact ones. This model gives a very detailed picture but can be complex to interpret. Finally, they used another advanced model called ordered beta regression. This model is quite powerful because it treats the data as ordered, meaning 0, the range between 0 and 1 are all on a continuous spectrum. It handles zeros and ones naturally without special treatment. With the ordered beta model, the effect of fluency on the mean outcome was still a bit uncertain, with a credible interval that included 0. However, the study found that fluency did seem to influence the boundaries of the scale. So what does this all mean? The initial, simpler analysis suggested that instructor fluency leads to better recall. But when the researchers used more advanced beta regression models, especially those that could handle the exact zeros in their data, a more nuanced story emerged. While fluency might not significantly boost recall for students who are already recalling something, it seems to have a noticeable effect on whether students recall anything at all. Watching a disfluent instructor made it more likely that students would get a perfect score of 0. This highlights a really important point in research. The way you choose to analyze your data can profoundly affect your conclusions. Using models that are built for the specific type of data you have, like proportions that are bounded between 0 and 1, is crucial. The original study, which used simpler methods, couldn't pinpoint why fluency might matter. But this more advanced analysis offers a potential explanation. Disfluency might cause students to disengage, leading to more instances of complete memory failure. This research is a great example of how advanced statistical modeling can reveal hidden patterns. It shows us that simply relying on standard methods can sometimes lead us astray. By using tools like beta regression, researchers can get a much clearer and more accurate picture of what's really going on. What are your thoughts on this? Do you find that instructor style impacts your learning? Let us know in the comments below. And if you found this breakdown helpful, please give this video a thumbs up. Subscribe to RUBIN'S Mind Lab for more science explained simply, and hit that notification bell so you don't miss our next exploration into the fascinating world of psychology. Thanks for watching.